Look at these two columns. They are literally standing close to each other. If you give each one its own footing, the two footings will touch. They will overlap. They will fight for same space. So in this kind of situation, what do you do? Today, I am going to answer that question, and I'm going to make it simpler than you think. Now, every building stands on something, and we call it what? The foundation. And the part that actually touches the soil and spreads its weight is called the footing. Now, think about your own body. Your leg is thin, but your foot is wide. The wide foot spreads your weight, so you do not sink into soft sand. Now, a column is the leg, the footing is the foot. Simple. Now, today we are going to look at two types of footing: single footing and combined footing. By the end of this video, you will know exactly when to use each other. Now let us start with single footing. Some people call it isolated footing, while others call it pad footing. But isolated footing and pad footing are the same thing. It is one footing carrying one column, one leg, one shoe. That is all about isolated footing and pad footing. You have seen it many times. Now go to any site. In that particular site, you must have seen that they've dug maybe a square hole, they've laid the reinforcement inside, they have casted the concrete already, then the column goes up from the middle of the square. That square part is called single footing. But why is it wide? It is wide because the column carries a very heavy load in a small area. If that load touches the soil directly, the soil will fail. So we spread the load. Bigger area means less pressure, same weight, but now the soil can carry it. So now a very quick question for you: if the load becomes heavier, what happens to the footing? So if the load becomes heavier, the footing becomes wider. So now it goes like this: the heavier the load, the wider the footing. The smaller the load, the smaller the footing. So now remember this: a single footing is one pad for one column. It is cheap, it is easy, and it works well when the soil is fair and the columns are far apart. Now here is the problem. Look at those two columns standing close. Each one needs a wide pad, but when you draw both pads together, they overlap. They are fighting for the same soil, and there is a problem. What about the column standing right on your property line? Your neighbor's land starts there, and you cannot spread your footing into his land. So the pad cannot sit at the middle of the column. It has to sit at one side. And when the load is not in the middle, the footing will want to tilt, like standing at one edge of a plank. So now what is the solution to this problem of single footing? That is where combined footing comes into place. A combined footing is one footing carrying two or more columns. Now the load from both columns spread over a large area. No overlapping, no fighting. And for the boundary column, the trick is beautiful. You join the boundary column to the column inside using one long footing. When you do this, the inside column then pulls the footing back, making it to balance. If both columns carry the same load, you use a rectangle. But if one of the columns carry a much heavier load than the other column, you use a trapezoid, thereby making it wider under the heavy column and narrower under the lighter column. Why are we doing this? Because we want the pressure under the footing to be even. Even pressure gives even settlement, and even settlement means no cracks. So now remember this: a combined footing is one footing having two or more columns sharing the load. So now what happens if you get this wrong? So the process of one part of the building sinking more than the other parts, that process is called differential settlement. So when one part of the building sinks more than the other part of the building, that is called differential settlement, and this can cause cracks along the doors, the beams, and the windows. So now what is differential settlement? Differential settlement is when one part of the building goes down more than the other part of the building. So when you see a building that's supposed to be standing horizontally, standing like this, just know that it is caused by what is called differential settlement. And this is one of the problems that causes differential settlement. The footing tilts and the column tilts with it, and that is the last thing any client or engineer will want. Now let me clear this myth. The first myth is that A lot of people believe that combined footing is stronger than single footing. This is not true. Strength is not the reason we choose it. Space is the reason, balance is the reason. If your columns are far apart and the soil is good, single footing is the best choice. Less concrete, less steel, less money. Choose combined footing when you are forced to, not because it sounds bigger. Second myth, some people say just make the footing wide and forget about calculation. No, that is also wrong. A footing that is very wide but thin, does not have thickness, will also crack in the middle. Width and thickness must be designed together. Now here is a recap. Single footing, one column, one pad. Use this when the columns are far apart. Combined footing, two or more columns, one footing. Use it when the pads would overlap, when the column sits on a boundary, or when the soil is weak and you need more area. Now remember this, shape also follows. Equal load, use rectangular footing. Unequal load, use trapezoid footing. Now if there's any other thing you need to catch from this video, it is this particular thing I'm about to say. Remember this line and you will never get confused again. A single footing is one footing for one column. A combined footing is one footing for two or more columns. Now if this particular topic made it clear for you between single footing and combined footing, I want you to like, share, subscribe and comment. Thank you and God bless you.